In today's note, we're going to be looking at the equation of a line in the form ax plus by plus c equals 0. So the first thing we want to do is rewrite the equation in the form y equals mx plus b, and then state the slope and the y-intercept. Two things we want to remember from our first unit. Our m value represents our slope, which is rise over run, and b represents our y-intercept. So the first thing we want to do in our equation, when we want to rearrange in this form, basically what we want to do is we want to solve for y. That's basically the goal when we're trying to get it into y equals mx plus b form. So if I want to get the y by itself, there's two kind of ways I can do it. We'll look at one way in this turn and one way in the next turn. So the first way, we want to get y by itself. So I want to get rid of this 2x. So I'm going to put a box around it. How do I cancel out 2x? Well, I have to minus 2x. And what I do to one side, I have to do to the other. One side cancels out. I'm left with y plus 3 equals negative 2x. I still need the y by itself, so I need to get rid of the plus 3 by minus 3 and do it to the other side as well. One side cancels out. I'm left with y equals negative 2x, and then because I can't subtract 3 from negative 2x because they're not like terms, I just put it at the end. And this is my new equation in the form y equals mx plus b. The last thing I need to do is state my slope and y-intercept. Slope again is the value that's attached to the x, so in this case it's negative 2. Y-intercept is the value on its own, so negative 3. For b, we're going to do the same thing, but we're going to try it in a different way. So I still want to get y by itself, but because everything's on one side, rather than move everything away, I'm just going to move the 3y over to the other side because then it'll already be on its own. So I'm going to minus 3y from this side, minus 3y from the other side. It'll cancel out on the one side, and I'm left with 4x minus 12 equals negative 3y. I still need to get the y by itself, so I need to divide, because the negative 3 is times y. I need to divide by negative 3, and then divide everything on the other side by negative 3 as well. This will cancel out the negative 3's with the y's, and I'm left with 4x over negative 3 plus 4, because negative 12 divided by negative 3 is positive 4, equals y. I can just flip these around if the form is more suitable to you. Either way, it's fine. To make it y equals negative 4 over 3 x plus 4. So I can just switch both sides completely and it's still fine. Then I just need to write my slope and my y-intercept. My slope is the value with the x, so negative 4 over 3. My y-intercept is 4, because the value on its own, a constant. In example 2, we want to do something similar, except now we're going to be solving for specific values. So if we are given a line 5x plus 2y plus c equals 0, and we know it passes through the point 4, negative 5, I want to determine the value for c. So if I wanted to, I could rearrange this initial equation right here for c. However, the only problem with that is I wouldn't get an exact value for c because I still have two missing pieces, the x and the y. What the question does give me, though, is a point for -5 that I can use to help solve, because we should recall that a point is just the value of x and y. Right? It has the two coordinates, the x value and the y value. So what I do, what I want to do, is when I want to take my original equation, 5x plus 2y plus c equals 0, and I want to substitute my points, or the values of my points, in for x and y of the equation. So I'm going to replace the x with 4. So instead of 5x, it becomes 5 times 4, right? Because remember, 5x just means 5 times x. 2 times -5 instead of 2y, plus c, still unknown, equals 0. Now I'm just going to go through and solve and simplify a little bit. 5 times 4 is 20, plus 2 times -5 is -10, plus c equals 0. I can still simplify the 2 and the 10, or the 20 and the 10. So 10 plus c equals 0. Now, with nothing left to simplify, I want to get c by itself. So I'm going to get rid of plus 10 by minusing 10, minus 10 from the other side. One side cancels out, and I'm left with c equals -10. And this is my final answer. I've gotten c by itself, and I have a specific value for it. For part B, it's the exact same thing. I'm given the equation of a line 6x plus by minus 24 equals 0, and passes through the point -1, -30. So this point here is of significance, because we are going to use it later. Here we want to find the value of b. So what I'm going to do, I'm going to take my equation again, 6x plus by minus 24 equals 0. And again, recalling that a point is just the values x and y, I'm going to plug those values in to the equation. So 6 times -1 instead of 6x, plus b times -30 instead of b times y, minus 24 equals 0. I'm going to go through and simplify. So I can do 6 times -1, which is -6, plus, it's going to be minus, because b times -30 is -30b, minus 24 equals 0. Now there are two things I can simplify. I can simplify by combining the -6 and the -24, because those two are like terms. I can't add in the -30b because of that b value. It makes it different. So what I can do, if I can combine those two, I get -30, still minus 30b equals 0. Now I want to focus on getting b by itself. I'm going to start with a separate term first. So instead of minus 30, plus 30, plus 30 to the other side. One side cancels out. I get -30b equals 30. Now I want to divide by -30 because the original operation is multiplying. Divide the other side by -30. One side cancels out. And I'm left with b equals -1 as my final answer. So a little bit different, but the same idea of taking the values of the point and plugging them in. So this is still working on canceling things out or solving for a specific variable. However, we have to substitute points or values in before we can do that. But it's still taking the same concepts that we've learned throughout the unit.